good to go. Well, do you guys need to talk about anything? Any questions?
No, I ended up watching the video with the tutorials last night, and it actually explained it, so I understand it so much more. I'm like, yay!
Yeah, I had to watch the video of him explaining how to do the problems, and then I was like, oh yeah, this makes sense. But when I was just reading it, it didn't make sense to me.
Yeah. Well, and it didn't help too. In some of the problems that they were doing, I was getting the answer wrong, and I'm like, how in the world am I getting this wrong? And then he explained it a little more in detail how you figure it out, and I'm like, oh, that's where I'm going wrong. Click.
Yep. Yeah, I did the same thing. Okay, well then should we take the quiz?
Let's do it.
Okay. Okay, you guys ready?
I'm ready.
Ready.
Okay, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. So 1.358. Okay, so it would be, sorry, I need to reread that. Okay, so is it 0.175?
That's what I'm getting.
That's what I got too.
Okay, cool. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, x, the distribution of the sample means, x, or this cannot be determined by the information given. Smaller standard deviation. Probably the distribution of the sample means, right? Because the sample means should all be pretty close to each other.
Right.
That's what I think. Yeah.
Okay, cool. Which of the following results implies that the spread in x decreases as the sample size increases? The normal distribution, the 68, 95, 99.7% rule, the central limit theorem, or the law of large numbers? I think it's the central limit theorem, right?
That's what I'm thinking, and I'm actually trying to see if I can look this up too.
Okay.
I think it's the law of large numbers.
Because I think the difference between them, okay, I wrote this down. Let me see. Yeah, the law of large numbers says that if the sample size is large, then the sample mean will typically be close to the population mean. And essential just talks about like the spread, the shape of the spread. So the spread should be affected by that one. I think is basically how I remember the difference. Yeah, the central limit theorem, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large.
Yeah.
What do you think? Should it be or the law of large numbers?
Well, because the law of large numbers says that it will likely be closer to the population mean, the sample mean will be.
Yeah. And this is talking about the spread in each individual observation.
Right.
I don't know.
I don't know either.
Standard deviation will get smaller. Oh, okay, wait. This says. Maybe it is the law of large numbers.
Yeah, that's
That because the standard deviation will get smaller. Describes that, right? It will decrease.
yeah.
Should we
Well,
say law of large
the
numbers?
central limit theorem is about the distribution, right?
So that talks about more like the shape, right?
Right. That's about the shape, the distribution.
Okay. So it should be law of large numbers.
I don't know. It gets a little confusing.
Which of the following results implies that the spread decreases as the sample size?
But I think we also try to word the question to make it a little confusing as well.
I know, seriously. I think I'm gonna go with the law of large numbers.
But that one makes more sense to me than the other one.
Yeah.
Because I know the central limit theorem is about the distribution.
Right, and this isn't talking about the distribution.
And the larger the sample size, the more normal the distributions.
Yeah, and that's not really what this is saying, right?
And that's not what this is asking, so.
Just go with the law of large numbers.
Yeah, I would agree. I can't find anything that says that the central limit theorem would be the answer.
My computer froze.
You're breaking up just a little bit there, but I can see you.
I think we lost her.
We might have.
But then we'd no longer be broadcasting and it still says live.
No, because remember the first week that I did it, I got kicked off.
Oh, was that you?
Yep, that was me.
I thought it was the other one that dropped.
No, that was me.
Oh.
I can
Sorry,
still
can
see
you guys hear me now?
Yeah, we can hear you.
Okay, sorry.
We thought we
I don't know
lost you
what
because
happened.
the screen went black.
I don't know why my thing isn't working, but I can still see Ashley and
Okay.
hear you guys. Okay.
Okay.
Sorry, that was
Yeah, we're all good.
okay. All right. So are we saying the law of large numbers then?
Yeah,
Yes.
that's what I'm good with.
Okay. Okay, cool. Me too.
See if it's wrong.
Okay, number 6. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? So we use the new formula from this week, right? This lesson.
Right.
Yeah.
So we do 160 minus 150.8
Mm-hmm.
divided by
And that's the top
8.8.
number.
Okay. Yeah, so that would be the top number. Let me think. Divided by the standard deviation. Sample sizes, though.
No.
So do we just do the normal, the other?
I would say yeah, since it doesn't give us a sample size.
Yeah, me
That's
too.
right. That's right. That's how it is. So I get 1.045.
Cool, me too. And then rounding it to 3 places, so 1.04, oh yeah, 45.
Yep, that's what I got.
Okay. And number 7, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Type in
So
that
we plug that in.
score, 0.045. So we just highlight the above portion, right?
Right.
Mm-hmm.
So 0.148.
Right.
0.148. Cool. Okay. A random sample of 5 students was selected to take the GRE. Their scores are all those numbers. What is the z-score corresponding to the sample mean of these scores? Round your answer. Okay, so this is with the newer
Yeah,
one.
this is with the new one.
So we find the mean of that. 160, 75. So the mean's what, 160?
160.
Okay.
Uh-huh.
These student scores. So we do.
So then we're squaring 5
Yeah.
Mm-hmm.
and dividing that by the 8.8. I should say 8.8 divided by square of 5.
Yeah. So I got 2.338.
That's what I'm getting.
Yeah.
Okay, awesome. Then what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So we just type in our z-score to the applet.
Mm-hmm.
338.
And
0.0097.
yep, that's what
Yeah, that's what I'm getting.
Okay. And then round your answer to 4 decimal places. Yep. Cool. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of 81 students who are sketched?
Should be less.
Should be
It's
approximately.
approximately normal. Since it's 81.
Yeah, because the sample size is larger
yeah,
than
that's
30.
right.
Right. Anything is 30 and larger would be approximately normal.
Yeah. What is the mean of the distribution of the sample means, the sampling distribution for all possible samples of that could be drawn from the parent population? What's the mean?
3.5.
Yeah, right?
Right.
Yeah, the
3.5. Okay. 3.5. What is the standard deviation of the distribution means? Samples of size 81 that could be drawn from the parent population.
Be the 0.7.
is 0.7.
Uh-huh.
Okay.
Maybe 0.077.
0.077. I don't remember how to do this one.
0.078. And around.
78. Can you remind me how you did that?
Okay.
Hey, Deborah, how did you get that number? I don't remember how to do it.
I gotta look at my notes here.
Was that what we did the last time? It's the sample size divided by, no, wait, let me think. The standard deviation divided by the square root of the sample size, right?
Exactly. So we're squaring 81, right?
I need to go back up, sorry. So the standard deviation is 0.7. The square root of the sample size
Okay.
of 81.
That's what I get.
Okay, me too. Cool, thank you. I forgot how to do that one. Okay, 13, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Okay, so we have to find the z-score?
Right.
Okay. .3. What's the standard deviation? It was 3.5.
Standard deviation is 0.7.
Oh,
the mean
that's right.
is 3.5.
3.5. Thank you.
Yep.
Of 81. Okay, so the z-score I got was negative 2.5714. So I got 0.005.
Did you say 0.005?
0.005.
Yeah, that's what I'm getting to.
Okay. Did you get that too, Ashley?
See, I get the first part of your equation right. I got the negative 0.257, but mine skews off to be 0.69409.
So wait, sorry, what was your z-score?
So I get it as negative 0.257, 0.69409.
257.
Uh-huh.
So when I typed it in the z-score, I typed it as 2.571.
Okay.
Maybe add that.
I didn't hear you say that one. I heard you say something else and then another number. I'm like, wait a second here.
Sorry. Yeah, I've learned with this, like if you have to, for the z-score, type in as many numbers as you can, and then you get the more accurate.
Yeah, I've learned that too.
Yeah, it's kind of picky about it.
And would you say
Yeah,
that you
0.
got for less than?
0.005.
Okay, I'm not getting that.
Do you have it less or on the left of the negative one?
I do.
What did you get?
I'm getting 0.3986.
3986.
25. Hold on. Maybe this isn't adding in this extra one here.
Yeah.
Nope, it is.
Okay. That's 2.571.
It keeps kicking my one out at the end.
That's weird.
Mm-hmm.
Try refreshing it.
That's what I'm going to do. Okay, 8.571. It doesn't like it.
It's still not doing it. It's 0.3.
Yeah, I get 0.3986. It does not like keeping that one in there. I even tried adding it in as a positive z-score and it wouldn't do it. Huh. I'm going to try seeing if I can pull this up again.
Okay.
Instead of refreshing 0.571. No, even kicking it out and bringing it back up, it still gives me that. What did you say you guys got?
0.00.
0.005.
Okay.
Sorry, that's weird.
I'll play with that. See if I can get that.
Okay. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? So it would just be 1 minus our answer.
So you're just shading the other way, right?
Yeah. So that's 0.995.
Right.
Okay. Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, than was observed in the sample. No, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are far away from the mean.
Right. So we're gonna shade both ways then.
Okay, higher and lower. So we just have to find the z-score then. .48. Okay. Okay. Do you guys think you got it?
I don't know if I did this right because I get for the z-score negative 4.966.
I'm getting 1.920.
That's what I got too.
So I'm doing something wrong.
So I
So
did.
you have to square the 48.
Yeah.
Square
So I did
48.
185 minus 177.6 divided by 26.7 divided by the square root of 48.
Right, you're dividing 26.7 by the square root of 48, which is 6.928.
Okay, what was the first number that you put in? I heard the minus the 77.6.
She's probably doing operations.
185.
So you're
Yeah,
doing
so I did
1.
185 minus 177.6. Because that's like the new value minus the mean.
Okay, so how did you come up with the new value then?
It's one that they gave us at the beginning. That
Did they?
the mean weight of passengers
Oh,
is 185.
that's why.
Right.
I have part of my problem cut off, so that's where I'm getting this wrong.
Oh yeah. That makes it more difficult.
7.4.
So now, do you have a TI calculator? I don't. I know you could probably put
really?
your equations in differently than I do.
Yeah. The TI probably makes it a little bit easier. It's the same one. I've had this calculator since high school, so it's old.
Same
It's
here.
like 10 years old.
All right, so now I'm getting the z-score 1.921.
Okay.
Awesome. I actually got 1.920.
That's what I got, 1.920.
But the next number is a 5, though. Don't we round up?
Oh, my next number is a 1.
Yeah, I don't get a 5.
Because mine shows it's a 5 after the 0.
Huh. That's weird. Why would... Okay, well, let's see what your percentage got, because maybe...
Yeah, mine is 1.9201.
You got the 1 too? Okay.
That's weird. Okay.
Wrong. That's fine.
No, I got 1.920. So I don't have a 5.
1 too.
1.9201.
1 point.
Okay.
Yeah, that's what I got.
I'm getting that same thing. I have to add the 8 in after my 3 when you square root the 48 and the divided by the 26.7. That's where I'm going.
Oh, yeah. Gotcha.
Okay.
So when you shade both extremes, I'm getting 0.55.
Yeah, I got 0.055.
Right.
Yep.
Isn't that what I said?
I couldn't tell. Sorry, you went out.
Okay.
But I assumed
Yeah.
that's what it was.
0.055.
Okay, perfect. Do you see that too, Ashley?
Uh-huh.
Okay, let's see. Ah, we got it right. It was the law of large numbers.
Yay.
Yay, we did good. Guys.
Woohoo.
All right. Well, any questions?
Nope.
I'm good.
Awesome. Thanks, guys.
Yep. See y'all
We'll see
Tuesday.
you next week.
See you Tuesday.
All right, sounds good. See ya.